Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about compound inequalities and solutions of those. So let's start with the worksheet that I handed out in class was called Compound Inequalities Review. And so let's start with example number 1. So example number 1 says this: x is less than 4 and x is greater than 6. So x is less than 4 and x is greater than 6. Now what we can say here is that the AND statement, anytime we have an AND statement here, what we're really saying is that whatever solution there is to the entire compound statement, it has to make both of these individual statements true at the same time. So really the question we need to ask ourselves is there a number that is less than 4 and greater than 6 at the same time to make this true? And the answer to that is no. There is no number that is less than 4 and greater than 6 at the same time. Another way you can kind of look at this is to compare the graphs of the two expressions. So here we have x is less than 4. That's going to look like this. Open dot at 4, shaded to the left, and then x is greater than 6. That's going to look like this. Open dot at 6, shaded to the right. So here, if we're looking for where the two graphs overlap each other for the AND statement, then we can see they're not going to intersect each other at any point. So here we can say the answer is really no solution, or in other words, graphing that would be just an empty graph. So no solution, empty graph. Now let's keep that same set of inequalities, but let's change this to an OR statement. Let's change this to OR. And here we can understand the OR to mean that we're taking one or the other solution. So really it's a combination of all the solutions that make this true and all the solutions that make this true. So quite literally what we're going to be doing is we're going to say if this is x is less than 4 and then we have the graph x is greater than 6, we're literally going to take both sets of solutions and we're going to put them together on one graph. So we can say this: x is less than 4, x is greater than 6, and that would be our solution set for an OR statement of this kind. So that concludes example 1 on the review sheet. Let's go ahead and move to example 2. So example 2 says x is less than 5 and x is greater than 2. So x is less than 5 and x is greater than 2. So here we can think of numbers, and again, the AND statement here, important to realize that this is where the two are true at the same time. So we have to think of a number that is not only less than 5, but is also greater than 2 at the same time. So some examples of a solution here would be like the number 3, or like the number 4, or perhaps 4.5. All these would be solutions to the compound statement here. But if we wanted to look at this as graphically, we would draw two graphs, and this would be represented by x is less than 5. And then here we could say that x is greater than 2 would look like this. And since we're dealing with an AND graph, we want to take where the two are true at the same time. So, in other words, where the two graphs intersect each other. And we can see that they really intersect each other in this section right here, in this middle section. So our final graph is going to look like this. Open dot at 5, open dot at 2, and we're going to shade the middle, indicating that the solutions are all in the middle of this graph, between 5 and 2. Now, if I change this compound statement to OR, if I change the compound statement to OR, then, again, the OR statement meaning that we choose one solution or the other. And we basically take the whole set of solutions here and we take the whole set of solutions here and we smush those together. So, x is less than 5 looks like this. And then x is greater than 2. And we're going to put all those together. So when we combine all the solutions here with all the solutions here, there's no place on the number line that is not going to be shaded. So in essence, we're saying that every number on the number line is a solution to this problem. So what we do is we shade the entire line and we say all real numbers. So this is an example like this with an OR as the compound statement would mean that this has all real numbers as a solution. So this concludes example number 2 on the review sheet. Stay posted for the second part of this, which will be examples 3, 4, and 5.